Knowledge workers spent a staggering amount of time trying to find things. Spread across fragmented tools, this constant search for context creates an answer hunt tax that drains hundreds of hours from every employee every year. To solve this friction, the corporate reflex is often to take a consumer-grade artificial intelligence, a standard large language model, and plug it directly into the company network. But treating an AI like a simple search widget creates massive vulnerabilities. Deploying an ungoverned language model directly into your internal systems bypasses access controls, exposing proprietary data and private permissions to severe internal leaks. True enterprise-grade AI depends on specialized architecture designed to govern data access from the ground up. That foundation is the Model Context Protocol, or MCP server. It acts as a strict toll booth sitting directly between your enterprise data and any external AI tools. Instead of granting blanket access, the MCP server enforces explicit allow lists. External tools can only read information inside Jira or Confluence if an administrator has explicitly authorized that specific pathway. This architecture enforces two strict privacy rules. First, Atlassian's AI, Rovo, will only search and retrieve data that the specific user already has permission to view. Second, your enterprise data is strictly firewalled. It is never used to train global third-party AI models. Beyond securing data, the backend must protect system stability. To manage the massive volume of automated API traffic, Atlassian uses a points-based rate limit system. Each request consumes points based on its complexity, meaning heavy requests deplete the hourly quota faster than simple ones. To prevent occasional traffic spikes from crashing the network, the system uses burst buffers. These secondary catch mechanisms absorb temporary overflows of API requests, keeping the shared cloud ecosystem stable during sudden periods of high demand. This invisible, highly regulated infrastructure manages both security and capacity, making it possible to safely scale autonomous AI across an entire organization. Moving up from the backend, the way users interact with these tools has been completely redesigned. The user interface overhaul focuses on maximum personalization, allowing individuals to customize navigation sidebars to fit their workflows. As part of this shift, Jira projects have been renamed to spaces. This reflects the reality that Jira is heavily used by non-technical departments like marketing, HR, and legal, who need workspaces that feel less like software development environments. Developers now also have access to the UI Modifications, or UIM API. This allows them to dynamically customize service management portals, automatically hiding or revealing specific input fields based on the user's context and selections. Modernizing and personalizing the interface clears away visual clutter. By making these highly technical back-end systems intuitive, everyday business users can engage with the platform effectively. We reach the intelligence layer, Atlassian Rovo. Powered by the Teamwork Graph, it connects isolated silos into a map of over 100 billion unique objects across your applications. Leveraging this, Rovo Search delivers results 78% more accurate than legacy tools. Beyond finding information, Rovo operates through agents. These virtual teammates act autonomously to execute specific skills per task, handling complex workflows like routing incoming service tickets, instantly pre-filling fields, or summarizing long comment threads. Because they execute actual work, these agents must be governed like any other automation. Administrators grant them least privilege permissions, requiring human confirmation before they can take high-impact actions, like notifying users or approving code. For software teams, there is Rovo Dev. This agentic AI lives right inside the developer's terminal, materializing code directly on the screen, reviewing pull requests, and updating tickets in real time. Through deep search, autonomous agents, and developer-specific tools, Rovo turns the Atlassian ecosystem from a passive repository where data sits idle into an active intelligence layer that participates in the work. This graph visualizes the macro outcome of this new architectural stack. By eliminating the friction of tracking down answers, AI integration saves the average engineer over 50 hours every year. But there is a vital catch. Rovo's intelligence is entirely dependent on the quality and organization of the human knowledge it searches. To address this, Atlassian bundles its core apps into the Teamwork collection. This suite is designed specifically to standardize how different departments plan, track, and document their work, so that knowledge follows predictable patterns. If your underlying workflows are chaotic, filled with outdated pages and abandoned tickets, the AI will simply ingest and amplify that chaos at scale. It cannot process a pattern that doesn't exist. Standardizing human work patterns is a strict technical prerequisite for achieving true AI autonomy. For administrators, the operational challenge has shifted towards separating AI tools that are merely enabled from the ones that provide actual value to the team. This requires baselining organizational waste before deploying AI. If you don't quantify exactly how much time your company currently loses to manual searches and redundant work, you won't have the metrics to prove any improvement later. To track this, administrators utilize the new Rovo AI Trends dashboards. These tools monitor monthly active users, track the volume of automated agent runs, and identify exactly how teams are engaging with the intelligence layer. Success in the 2026 Atlassian ecosystem requires a change in perspective. Organizations must stop viewing AI as a simple switch to be flipped and start managing it as a symbiotic, engineered partnership between human workers and governed intelligence.